Hello, 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 everyone. We're going to give ourselves about another minute for others to join, and then we will get started with advantages of AWS with Spinnaker. I hope everybody is doing good today. I'm going to give it about another 30 seconds. Welcome, 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 everyone. My name is Marky Jackson. I am Director of Open Source Software at OpsumX. I am so thrilled to have everyone here today as we talk about the advantages of AWS with Spinnaker. I'd like to first and foremost thank each and every one of you for taking the time to let us come into your computer to talk about some technical items. Well, we know that the episode is advantages of AWS with Spinnaker. Let me tell you a little bit about today's speaker. Anup is a senior DevOps engineer with OpsumX, and I'm super pleased to have him. He's got a very interesting story. He's an awesome person, and he's extremely technically talented. So just a few announcements and housekeepings before we get started. If you have any questions during the presentation, please type them into the question box in the Zoom control panel. We'll address those during the presentation when appropriate. And then during the Q&A session at the end, we'll also be asking several poll questions during the webinar today. These questions are to help the presenter get an idea of who's in the audience so we can customize and adapt presentations. These questions are completely optional, but if you answer them, we'd appreciate it, and we'll share the poll results with you when we are done. Next slide. For those that are not familiar with OpsumX, we're a venture-based startup based in Silicon Valley. We help enterprise organizations modernize and transform their software delivery with Spinnaker. We provide enterprise-ready distribution of Spinnaker, and that's called Open Enterprise Spinnaker. We have managed Spinnaker as a service, as well as Spinnaker onboarding, training, support services to help enterprises adopt and scale continuous delivery and Spinnaker in their organization. Next slide. We're going to go ahead and start off with a little poll here, and you should see that pop up right here. And number one is, are you currently doing continuous delivery? If yes, what percentage of your production, what percentage are you using for dev, test? And then the second question is your organization currently evaluating or using Spinnaker? So I'm going to go ahead and let everybody get a chance to just answer some of those questions. I'll wait about 15, 20 seconds. Awesome, awesome. I'll give it about another 5 seconds. All righty, let's see what we got here. So we have about 17% are. Let's see here, more than 50%. That's pretty darn good. We've got about 3 people that said they're not currently doing continuous delivery. We have 50% that are not evaluating Spinnaker. We have 1 person that is actually using Spinnaker in production. That is great, as well as another individual currently evaluating Spinnaker. Super, super awesome. So let's go ahead and next slide. So without further ado, what I'm going to go ahead and do is I'm going to turn it over to our awesome presenter today, Anup. Anup, please take it away.
Thank you, Marky. Hello, everybody. Good morning, good afternoon, and good evening from where you're joining today. And thank you for joining our session. Hope all of you are doing well and staying safe during this pandemic. So, as Marky has mentioned, today's topic is about the advantages of AWS with Spinnaker. So before I get into the deep dive of advantages, I would like to start over with the current transformation by major enterprises to faster app delivery. And to adapt this kind of a process, we know most of the enterprises are adapting into continuous integration tools like Jenkins, GitLab, or CD continuous delivery tools like Chef and Puppet. And as part of this, there are a couple of challenges which are noticed, like the processes coming to the processes, like meeting the SLA during the deployment cycle, because obviously when we are talking about maintaining your continuous integration and delivery process using Jenkins, most of your deployments or build process, everything executes on a custom script based, uh, which is basically tough to implement on a multi-cloud deployment platform. And not only this, along with this, we talk about manual verification process, wherein there is a human intervention required, you know, to go ahead, check certain few things, and then approve it or reject. So all of those processes are being implemented right now, which sometimes impacts the SLA of your release process. Of your product release, because we not only talk about delivering the product, but we also talk about meeting the compliance of the enterprise. They are whoever is trying to execute the continuous integration and delivery. So considering these as some challenges, and most enterprises are targeting on on a faster delivery pace, what we have thought is Spinnaker would be a right platform uh, to give you a faster deployment pace with confidence, a high velocity deployments with confidence. And why is that? Because Spinnaker, for some of who is not familiar with Spinnaker, so Spinnaker is it's initially developed by Netflix in the year 2014 or so, and it's battle tested in Netflix in the production. When I say battle tested, it's actually a thoroughly tested product. Wherein I say Netflix, even as of today, on a day-to-day basis, they execute around 9,000 plus deployments on a day. And in the same year, 2015, the product, the Spinnaker has been open sourced by Netflix, and since then, Spinnaker is backed by major tech giants like Google, Microsoft, Target, along with Netflix, and the organization list continues. So, a brief introduction about Spinnaker, as like, as we are talking about multi-cloud deployments, there are challenges with multi-cloud deployments with the current CI/CD tools available. Spinnaker is a native multi-cloud deployment tool, which you can deploy on any cloud platform that is available in the market right now. And it is not only on the cloud platform. If you have a on-prem systems which is behind your proxy, you can go ahead and deploy Spinnaker in that environment. There are quite a bit restrictions for the installation process, but still it's a doable method. And with Spinnaker, as I've mentioned earlier, with Spinnaker, your deployment, Spinnaker takes care of deployment phase at a high velocity with confidence. And some of the primary features of Spinnaker is, application management, which basically handles the clusters to configure, delete, disable, and eh, deploy cloud resources like server groups, security groups, load balancers. So basically, anything in that matter of fact can be controlled from one single UI. You don't have to juggle between multiple UIs when you have Spinnaker in place. The tool itself is built with pluggability in mind, right? And automated releases. Yeah. So, like we say, Spinnaker has built-in best practices. Um, so, some of the best practices are, which we call it in the current scenario, like red black, which is also called as blue green. It does nothing but, if you're doing any of your deployments to your production, and you want to maintain a minimal downtime, let's say a very least or the minimal downtime, all red black does is your previous version traffic will be diverted to the latest version as per the approval basis. And in this cycle, you will have a detailed analysis of your deployments done, and uh, you'll have a detailed analysis of your deployment done. Spinnaker itself has an canary analysis tool, which we call Kayanta. So Spinnaker is basically developed with multiple microservices in it. It is a high scalable tool because the tool itself comes with multiple services in it. Like the UI has a different service called deck, and API endpoints are communicated by a different service called gate. And to communicate with cloud providers, multiple cloud providers like AWS, Azure, Oracle Cloud, Kubernetes, OpenShift. So to communicate with all of these cloud providers, Cloud Driver is used. And for your authentication purpose, Fiat is one of the microservices that is used. And for continuous integration configurations, Spinnaker, for continuous integration configurations, IGOR is the service that is used. And Roscoe is one of the service which is used for baking immutable images, which is nothing but, when you're planning to push your code into your cloud provider, like say AWS, you wanted to deploy it as a image. Roscoe takes care of building it as an AMI using Packer as a service. It builds it as an AMI and pushes it to AWS, and then the deployment goes further. I'll show how the functionality works during the demo. So we have already spoken about application management and what it does, like managing your server groups, security groups, and load balancers. Along with application management, the other core feature Spinnaker handles is application deployments, which is nothing but creating and managing your continuous delivery workloads, which I call in simple terms is nothing but pipelines. Spinnaker pipelines usually consist of multiple stages, and all of the stages are inbuilt with Spinnaker. Some of the stages that I would highlight in today's session is bake, baking, which usually does nothing but bakes and immutable images. When we talk about cloud providers like AWS, Azure, Google Cloud Platform. And when it is about Kubernetes, it bakes your images into a container and then pushes the deployment to your Kubernetes or an OpenShift cluster and deploy the images to your clusters. Let it be Kubernetes cluster or your ECS cluster, or Spinnaker also has a direct AWS integration, which can take your artifacts, create an EC2 instance, and deploy it as an instance as per the configurations that you have declared in Spinnaker. And if you're planning to run a Jenkins job, you don't have to get back to Jenkins UI, search for the job, and run it. So you can configure your Jenkins or Circle CI, Travis CI. In that matter of fact, if you are planning about any other continuous integration tools like Bamboo, Bamboo is officially not certified with Spinnaker, but with the custom webhook, we can go ahead and plug in any kind of tool that you have in mind with Spinnaker, which can easily support and give you a seamless experience of continuous delivery approach. And not only the pipeline stages, as I've mentioned, deployment strategies like red, black, or blue, green. This makes Spinnaker unique from the current CI/CD tools that's available in the market, because the downtime of your deployment, the downtime on your production is very minimized, because all of the traffic shaping and everything from your previous version to the latest version is handled by Spinnaker on the go while the deployment is getting executed. And alongside, some of the other built-in features that Spinnaker has is security, which I have mentioned earlier. So Fiat handles all of the authentication and authorization part of your Spinnaker. You can configure LDAP, ADFS, and if you're preferring single sign-on, SAML, or any other SSO platforms, single sign-on platforms that you're using, can be configured with Spinnaker. And coming to compliance, at the application stage, we can do a role-based access control of your pipelines to ensure which user. So if you're having a development team, a developer team, whom you would prefer to provide access only to the development environment but not to the rest of the environments, you can control the role access for that particular user group at the application level. And these when you provide the permissions at the application level, automatically Spinnaker can understand and can publish the permissions accordingly in the pipeline for that particular user group on the go. And the best part is auditing. While you're executing your pipeline, when you configure the alerts, all of the approval groups, so you can, if you're planning to execute an automated canary analysis, you can obviously use Kanta. With automated canary analysis, you don't have to manually go ahead and approve, but on a production environment, it is always well suggested as a best practice to have one approver to usually monitor all the bugs, whether if everything is fixed or not, and then approve. So for that purpose, the auditing makes it very easy, because Spinnaker, on the Spinnaker UI itself, you can have a track on to which user the alert is triggered, and whether if all the check is done properly or not, and approval is triggered accordingly. So basically all of these are validated in detail, and this kind of information is available on the UI. You again don't have to juggle between multiple pages. The beauty of Spinnaker is everything is available in one single UI. Start from your pipeline, your deployment details. I mean, when I say your deployment details, your cluster details, your load balancer infrastructure, and your security groups, the VPC and subnets of your cloud providers. Everything can be seen on one single UI. And with this, I would like to jump onto in detail the walkthrough of advantages of AWS with Spinnaker. So one of the best best advantage that I can say is, if you have any hesitation to provide access to your developers for them to scale up or scale down the AWS instances by logging into the AWS console, you don't have to worry. From the Spinnaker console itself, the users will be able to scale up or scale down their instances as and when required. All they have to do is log into the console and play around. When they do the scale up, the instances will automatically start spinning up in the AWS. And likewise, creating load balancers, creating security groups, managing VPC and subnets, and the best part is immutable images, which eventually pulls all of your code related artifacts from your CI. In my current scenario, I'm using Jenkins, so it basically pulls in all the artifacts from Jenkins, bakes it as an image, and then pushes that image to a S3 bucket. And then AWS deployment for the AWS to deploy, for Spinnaker to deploy that image on AWS, all Spinnaker does is pushes that deployment into AWS. We need certain secrets to be provided, which is nothing but your access key and secret key. This also, you don't have to provide it directly to Spinnaker. You can save your secrets on your source code management tools, like say GitHub, Bitbucket, and set it up as a dynamic account to Spinnaker, and Spinnaker can easily communicate, capture all the secrets it needs, and play around as it needs. And while we're talking about immutable images deploy and all that, ECS deployments, you can deploy your containers to an ECS cluster, to a Fargate cluster with minimal charges. And if you want to bring up, if you want to maintain a higher level infrastructure of your ECS cluster, you can easily deploy your images by creating Fargate is basically, I think you already know the serverless concepts of Fargate. So most of your deployments can go without any servers, and you'll still be able to access your application. Whereas if your application prefers higher infrastructure limits, then you can still go ahead and push your deployments by creating some infrastructure and adding some EC2 instance to that. And persistent storage, Spinnaker uses S3 bucket and as a persistent storage. And the advantage of having configuring S3 to Spinnaker is basically your images or any of your code that you're storing. So by default with Spinnaker, Minio comes as a persistent storage. But one of the drawback that we have is, whenever the Minio container goes down, there are high chances of your data loss. Whereas coming to AWS S3 bucket, your data is stored in the EBS back at the S3 level, and if there is any issue at the Spinnaker, when you bring back the Spinnaker when you bring back your Spinnaker, all of the data will be, since most of your data will be stored at the S3 bucket, Spinnaker can easily communicate, resume back at the same place where it is lost. So you will have your Spinnaker back with zero data loss. And Docker, if you're already using a Docker registry, ECR is another level of Docker registry where you can pull and push your images into an ECR as a Docker registry and deploy the same images to your Kubernetes. Let it be a local Kubernetes cluster or a EKS cluster or any Kubernetes cluster. In that matter of fact, you can manage all of this from the Spinnaker pipeline itself. And along with this, deploying your applications to EKS clusters makes it seamless deployment experience for you, which you can create a pipeline with multiple stages and push the deployments to your production, and access your Kubernetes clusters from the Spinnaker UI itself to identify where your containers are deployed. And if you want to scale up your containers to multiple numbers, you don't have to go to your Kubernetes, edit the replica sets, and do the scale up or scale down. You can again do all of those activities, perform all of those activities at the Spinnaker level itself. And not only deployment is the advantages, the next level of advantages that I would introduce to you is infrastructure management. As we all know, most of us are using Terraform to manage our AWS infrastructures. But there is always one risk when we are using a Terraform plan, which is if we don't concentrate or if we don't keep our eye open, there is high risk of the delete stage getting executed and losing all the data that we have on the infrastructure that we have created. So with Terraform integrating with Spinnaker, this usually becomes a hybrid multi-cloud platform to manage your infrastructure. The reason I call it hybrid multi-cloud platform is you can create everything in a pipeline. Basically, all of your plan details can be created in a pipeline. And if you are planning to share your Terraform plan across your team, your secrets can be managed in a source code management with a dynamic account configured along with Spinnaker. And you don't have to maintain basically multiple repositories to store your secrets. The secrets that you store for Spinnaker, the similar secrets can be used by Spinnaker to push it to Terraform, and then Terraform can pull the secrets and just make the job run on the go. And for each and every stage, start from Terraform initialization till the plan execution and the delete job. So basically, for each and every stage, you can make the Terraform stage wait until you or someone approve it. You can go ahead and look at the output on the Spinnaker UI, and a detailed output will be you can see the detailed output as per how you have declared in your Terraform plan. And once if you are satisfied or if the output meets your requirement, only then you can let the next stages execute, or else you can just terminate it and Spinnaker just kills the initialization or the apply job. So basically at any point of time, if you want to terminate the plan, you can just terminate it at the pipeline level itself. And again, since we already know what all Terraform can do, which when we try to integrate a Terraform plan for AWS, you can create auto-scaling groups, you can manage your S3 bucket, you can create multiple VPCs, you can create an EC2 instances, you can manage your Kubernetes cluster, you can scale up or scale down multiple load balancers using Terraform plans. And for all of this, you can just go ahead and execute one single pipeline that's available in Spinnaker, and it will make your job simple and straightforward on the go. So with no further ado, I will walk through the demo of our pipelines today. So these are the few pipelines that I have to demonstrate to you. Um, so first thing that I would say is the AWS integration with Spinnaker. It is something which you need to configure, and the configuration steps are provided in the document, in the slide that I'm sharing right now, which you'll get an access of the documents at the end of the session. And so since you'll be getting the deck, so I believe you'll be getting the access of the documents, which has in detail steps of how to configure AWS and how to execute, how to create the pipeline, how to manage the pipeline and everything. However, I'll just walk you through the basics of how the pipeline works right now. So these are the basic pipelines that I have, which basically uh, builds my artifact from Jenkins and bakes it and deploys it on my dev, and then promotes the deployment to production. So if we look at the in detail at the configuration stage, I have triggered automated triggers wherein once if the code is committed by the developer into my GitHub, it automatically triggers the pipeline. Right now, I have disabled the trigger because of my own reasons, but when we enable the trigger, as soon as the commit gets in, the pipeline triggers and it does its job. So, and this is where we have all of the configuration details of the artifacts, where does the artifact come from and everything. And at the next stage is where I have set up my Jenkins, which has my my Jenkins repository, my Jenkins stage, where the artifacts will be built and send it to S3. So once the build is done, each and every stage is dependent on the previous stage. So the build stage is not doesn't depend on anything. But when we go to bake, if you look at here, bake is completely depending on the build stage, because once the build is successfully executed, it calls for the image that is built in the current with the current stage, and these are the few details that we need to provide. So at the bake stage, the bake configuration, right now I have the default values like Ubuntu, Trusty 14.04 and Windows. But if you're willing to add in any other operating systems like CentOS, Red Hat, Fedora, all of the operating systems can be added, but there are minor manual changes that need to be done at the back end, wherein you need to edit few configuration files in Spinnaker, and then all of the operating system details can be seen in the Spinnaker UI. And you might have this question like, what is this base name and the AMI? So the application that I'm deploying right now has one basic requirement. It needs Java to be pre-installed on the AMI that it is using. So in this particular AMI, I have Java installed, and what the bake stage does is, using Packer as a service, it pulls in all the artifacts from Jenkins, and it just bakes the artifacts into this particular AMI. And in the AWS, it will create an AMI. So let me show you what happens while the bake stage is executing. I'm not going to execute this pipeline today because it's going to take approximately around 23 minutes duration. So I'm not going to execute the pipeline, but still, since the pipeline is already executed, I'll be able to walk through the entire process on how it works. So here I see the build details, the latest, the job that got executed, and the latest build. And once the build is successfully executed, it pushes on to bake. And at the bake, if I click on the bakery details, it will first initiate an AMI creation, which will get created at the AWS. And Spinnaker will start looking out for the AMI that we have provided in the bake stage, which is nothing but the AMI, the base AMI name that we have provided here. And then it starts collecting all the artifacts from the Jenkins, and it tries to communicate to the S3 bucket that we have configured, and it starts pushing the artifacts. It keeps baking. So this baking process, what happens is it spins an instance, and it pushes all the artifacts into that particular instance. And at the end of the stage, you should be able to see it will try to stop the instance, and it adds all the tags into the AMI to try to stop the instance. And end of the stage, in whichever location you have selected, you can add any number of regions to your Spinnaker. Right now, if you look at my configuration, I have US East 2 and US West 2. So similarly, you can add any number of regions, and you can push your AMI to all the regions at the same time if you prefer to do that. And it just saves the AMI in the preferred region. And once the bake stage is done, then it pushes on to deployment. And in the deployment, this is where you define your VPC and subnet details, your load balancer details, and the environment that you would like to deploy, the sizing of the environment, basically all of those details that you would like to configure for your deployment. This is where you configure. So here, if you see, this is my AWS account, the region that we select, and I have the VPC subnet details that directly pops up. So these details doesn't come up by default, as I've already mentioned. It needs certain IAM roles and everything for Spinnaker to identify all of these details, and the configurations need to be done. I'll be sharing the documents to you, the relevant documents to you, so that you can play around at the end. And the deployment strategies that I've mentioned while I was walking through the deck. So Spinnaker has inbuilt deployment strategies. So custom strategy, you can define anything that you want. And Highlander strategy, it basically destroys all the previous deployments that is active right now, and it only keeps one version, that is the latest version that you're deploying right now. This is not recommended for production because, as it says, the rest of the previous data will be lost completely. And red black, which is otherwise called as blue green, is what is recommended for production environments, production grade environments, because it just disables the previous server groups in the cluster and it doesn't remove them. You will be able to see the previous server groups still available in your cluster, and whenever you find out any issues, all you got to do is just go to the cluster and roll back. It can roll back to the previous server group within no time, and the traffic shaping will be taken care by Spinnaker on the go. And you see the target groups, the load balancer that we have configured. So at the drop down, you should be able to see the list of load balancers that's available and the firewall settings that you have defined. So for the instance type also, you don't have to basically check with AWS console for the sizing of your environment that you prefer to. You can just go ahead on the go, start from minimal usage till high memory. Basically all the configurations are available in the same UI. And the number of instances that you would like to spin up, you can define it here, or else once the pipeline is executed, if you want to spin up more instances, you can define it in a different place, which I will show you once I pass through the configuration stage. And the availability zones is something which you can select which you can keep it automatic, so that it will just select all the regions that's available, all the zones that's available, or else if you keep it manual, you can check it as per your requirement. And these are few details that's mandatory: the health check type and termination policies, the keys that you needed, because if at all you're planning to log into that instance and check some of your prerequisites, so you need to define a key. By default, Spinnaker doesn't ask for a key, but if it is suggested to provide, so that you'll be able to log into the instance. And this will be the simple configuration that we have. And right now, if you look at the prod deploy here, you will not be able to see any deployment here. The reason is I am triggering a pipeline from a pipeline. I have this for my development, and if my approver clicks on approve, because the code that I'm trying to deploy is successfully validated, and if everything passes on successfully, if the approver clicks on approve, only then the deployment will be passed to production, and it will trigger a different pipeline that's available, or else it will just roll back the cluster, which will simply go ahead and reverts back to the previous image that's available. And in the production, the configuration will be slightly different. Instead of we using bake, we'll try to find the image from cluster, which will be the deployment that is done on dev. We'll pick up the previous deployment from development, and we'll just push the same image to production. We'll not use any other image, because that image is tested, regression testing is done, and that is the reason we'll just pick the same image. So we define the cluster group here, and then the server group selection, you can select anything, any of the components that you have here. Since I need the newest image, I'm using the newest image that's available, and it will just pull the deployment to the production. And here, if you look at the strategy, I'm using a red-black strategy here, which simply disables my previous version and enables my latest version. That matter of fact, so if I click on clusters here, this is where I'll be able to see the deployment details. So this is my dev deployment, which is a Highlander deployment strategy, which basically terminates all the previous deployments and keeps only the latest deployment available. Whereas when we look at the production deployment, it currently routed 50% of traffic. And here, if you look at the image, you'll be able to see 100% traffic routed to it. Oh, my bad, sorry. So you'll be able to see 100% traffic routed to it. And if you prefer to access the application, you just click on this part. It'll for some reason, I don't think the load balancer it's not picking up. I'm not sure what's wrong with that. All right, so just to continue, if we click on this icon, usually it should pop up with the load balancer, which will show your application details. And in the same UI, if you click on Amazon, you'll be able to see the load balancers that is configured with this particular account, and the deployments that is assigned for this particular load balancer, and the firewall configurations as we speak. So the number of firewalls that we have, and the deployments that is assigned to this particular firewall. Lambda is also supported by Spinnaker. You can create Lambda functions directly from the Spinnaker UI. You can define your Lambda functions directly here. on the go, you will just be able to create your Lambda um, from the same UI. You don't have to. All you need is a valid function that you have created. You just put the content here, and you'll be able to create Lambda functions from the same UI. And right now, since we speak about, we have already spoken about AWS integration, the pipeline of AWS integration with Spinnaker. The next one I would like to showcase is Terraform, how it works. So right now, I have two simple pipelines, which basically creates a VPC and creates an EC2 instance. So if you look at the pipeline configuration, I have multiple stages: the plan initiation, manual judgment, apply, and then I have a judgment here, and then the destroy job. So each and everything, there are a few mandatory fields that I have, which needs to be filled, and these are also available in the document. If you get through the document, you'll be able to understand in detail on how that works. And the output part of your Terraform plan, you just click on the execution details and the console output. I think the data has been deleted here. So this is where you'll be able to see the entire output of your plan execution. I have. Yeah. So I think the data has been removed. This is my demo environment. So we usually keep recycling it. So yeah, this is where you'll be able to see a stage-wise output. You'll be able to see the output, and the next stage is completely completely depends on the plan job. And if you see here at the manual judgment, so each and every stage is dependent on the previous stage, and in the Terraform plan that I'm using, I have the output values defined, which basically calls for each and every stage that gets executed. So let's say if my Terraform plan gets initiated, then it waits for the exact output that is being called out for. And once if the relevant or the reasonable output is received by the apply job, then the apply job gets executed successfully, and it creates an instance in the AWS. And not only creating an infrastructure, in the same pipeline, you can also add in a deploy stage, which can basically deploy, or if you are planning to deploy a web image by adding some uh, Apache or any of the configurations, you can basically add all of those custom details into the pipeline as a custom pipeline, and you can just push it as a pipeline on the same pipeline. You don't have to go through multiple pipelines or multiple stages. If you want to trigger a multiple pipeline, that is also possible. And with the same job, with the same Terraform stage, you can not only create or manage an infrastructure, you will also be able to deploy and destroy your infrastructure at the end of the stage. So these are the documents that helps you to, if you're, so for some of you, I think are exploring Spinnaker, or some of you are not even using Spinnaker. So if you have a AWS infrastructure, if you have AWS account, from OpsMix, we have provided a solution with Spinnaker on the marketplace. It's published already. It's of no cost. It's free of cost. You all you have to do is just launch your instance and wait for 15 minutes. You'll be having an active running Spinnaker within 15 minutes time, and you'll be able to access your UI at the end of the 15th minute. And these are the documents you can use to integrate AWS with Spinnaker, integrate ECS with Spinnaker. And if you're planning to integrate Terraform with Spinnaker and manage some of your AWS Terraform plans, you can go ahead and use this document. And other documents, if you're exploring on Spinnaker and you want some Spinnaker tutorial, you can just click on this GitHub link and access. There are more interesting blogs available in our website. You can reach out, you can access blog.opsmix.com or docs.opsmix.com. There are more interesting topics and more blogs. We have a couple of more blogs which we'll be releasing. So all the blogs will be available in the in blog.opsmix.com. And we have pre-recorded webinars that is already published. You can access the link that is provided here. You need to just register and watch the on-demand webinars as you need. If you need any further support from my team, you can just join us on Spinnaker team slack.com. There are already 10,000 plus users in the community, so we'll be happy to see you there, and we'll be happy to help you. If you directly want to reach out to me, you can just drop in a mail at hello@opsmix.com. My team is always open to respond back to you. With this, I would like to hand it over to Maki.
Awesome, awesome, awesome. Thank you. That's very great, Anoop. This has been a really interesting demo, and we do have a few questions from the audience, and it's probably a good time to start the Q&A. We're going to take some questions. There's two ways that you can ask. You can first submit your question in the control panel of Zoom, or you can just raise your hand directly, and I can unmute you if we have enough time. First, what we're going to do is, before we move to the Q&A, I'm going to put up a little poll question. In this poll question, usually as a follow-up, we get asked quite often to provide the slides. And what I'm going to go ahead and do is put this poll up. Give me just a second there. You should see it right there. What this will do is it'll, if you'd like to be presented with slides, or if you'd like Spinnaker training or onboarding or support, or schedule a demo with the OpsMX Open Enterprise Spinnaker, or you can schedule a complimentary CD strategy workshop. I will leave this up. Definitely go ahead, fill that out if you'd like to get the slide deck. I'll give it a few more seconds for everyone to do that. Hope everybody's doing okay out there in Zoom land. I'm going to give it about another 30 seconds just to be on the safe side. Awesome. Just about another 5 seconds. If you'd like to, you got a couple more seconds to get in there. Awesome. I am going to close that out, and we're going to go ahead and move to the Q&A. So our first question is from, actually, nope, I don't have that. Can I use a build parameter in Spinnaker?
That would be a yes. We will be able to use a build parameter. Yes, you can.
Yes, I do believe there's a field that you're able to use that on.
Yeah.
Second question is, what's the difference between AWS with Spinnaker and Terraform with Spinnaker?
Okay, so AWS with Spinnaker basically allows you to deploy your code, which basically creates an immutable image along with your application artifacts and everything. And then you'll be able to deploy your application as a EC2 instance, and you can scale up or scale down. Not only that, you can also manage your load balancers. There are some similarities, like you can create load balancers, VPCs, subnets, security groups, and everything. But the one difference is Terraform limits basically only in managing your infrastructure. Whereas with AWS, you can, push your artifacts into your infrastructure. And then when I mean artifacts, push your application as an image into your EC2 instance and make the deployment going uh, while your EC2 instance is running. And if you want to terminate your EC2 instance, you can also terminate the server group from the Spinnaker UI, irrelevant of you using a Terraform plan. If you want to use it, you can use it, or else it is not preferable.
Okay. I got another question here. It says, from your perspective, what industries are leading in the deployment and rollout of CI/CD tools and processes? What prerequisites from people, process, technology perspective did they have to implement across dev, QA, security, and operations teams to realize the potential benefits of CI/CD? I'm going to answer this one, and I'm going to say that I see a lot of different industries that are using CI/CD. And it's not even some of your traditional industries. I'm seeing a lot of motor companies, automobile companies that are using CI/CD. I've seen a lot of AI driving companies using it. I've seen pharmaceutical, biotech companies using CI/CD. Usually the reason they're wanting to use these type of tools is one of the biggest things I've seen that's been huge lately is ML ops. And they need to be able to train models, and they want to have CI/CD to do that. Hopefully that answered your question. We do have another question in here. What advantage will a developer have by integrating AWS with Spinnaker?
That would be pretty simple. You don't have to give him your AWS access. You can ask him to, play around with uh, AWS instances, like creating an instance, or if you want to manage multiple instances, I mean, scale up multiple instances on the go, or create a load balancer and assign it to your application, create a VPC and assign it to your deployment. So basically, all of those details, your developer can basically create it from Spinnaker instead of accessing the AWS console.
Excellent, excellent. Thank you for that answer. I have another question that says, can I get customized on and off check buttons in Spinnaker pipelines?
Yes, that's as I have mentioned during the demo of Terraform. Custom webhook stage is something which you can plug in any kind of features that you want. So yes, you can do.
Awesome, awesome. Can I go ahead and get the next slide? So as I mentioned before, this is all the time we have for the Q&A. If you'd like to get in touch with us, you can definitely do so at opsmx.com. You can check our calendar for upcoming webinars and tech talks, as well as blogs and other educational content on Spinnaker and continuous delivery. I would like to thank our presenter, Anoop. That was an awesome job. Thank you so, so much. I'd like to thank everybody that attended. And if you have any other questions, definitely reach out to us. We are available on Slack. We are available. You can contact us through OpsMX. And I thank everybody, and have a great day, evening or night. Thank you all.